Hi there, everybody. We're going to take a look at a basic divisibility problem and just kind of walk through a proof for it. We've done some proofs now, both induction, like I said, and proof by contradiction. And so we're going to be continuing to kind of strengthen our formal proof skills. So you should be following along and paying attention to the structure and the reasoning that's being used. And using that when you write your own proofs, okay? The other thing I'm just going to ask for some feedback on at some point if you get a chance is I'm kind of curious what you think of the dark mode background. I decided to try something a little bit different for this video. Okay, so the proof that we're going to do, or the statement that we're going to prove, is that if A, B, C, and D are integers, we want to prove that if A divides B and C divides D, then AC divides BD. So what I mean by that is this statement right here says if A divides B. So this is just another way of saying that A is a factor of B. So for instance, like I could say if 2 divides 6, that would work there. And then if 3 divides 4. Those would be specific examples. So we can't use those to make this proof, but just to give you an idea of what that statement means. Okay? So the first thing we're going to do is go ahead and pick a different color. We're going to say, hey, let's let L and K be integers. Okay, and so then by the definition of divisibility, if A divides B, then B is equal to some integer L times A. And again, if we think of our example of 2 and 6, this is essentially saying that 6 equals something times 2. So in this case, we know that L is 3, if we were talking about that specific example. Okay? And if C divides D, then we know that D is equal to some integer K times C. And both of these are just based on the definition of divisibility, with a little bit of notation thrown in there. Okay. Now here we can use a little bit of just straightforward kind of algebraic math that we're used to. I have these two equations. Both sides are equal to each other, so I can use a property of equality. So I'm going to multiply the left sides together, so then B times D is equal to the right sides multiplied together. L times A times K times C. Okay? Does that make sense? One thing I should point out is at any point, pause the video, slow it down, whatever you need to do to make sure you're kind of following along. The next step is we're going to use the fact that multiplication is both associative and commutative. So we can rearrange the multiplications and regroup them on the right-hand side. So I'm going to rewrite the right-hand side as the product of L and K, times the product of A and C. That all equals BD. Okay. Now you might notice, I'm just going to grab a different color here. We have L times K there. Well, L and K, as we said before, are both integers. And it turns out that the integers, which you may remember we use that kind of funny Z with the double line there, are closed under multiplication. And all that means is that if I multiply two integers together, I get two more integers. Okay, I'm not going to multiply two integers together and suddenly get an irrational number. Or I'm not going to suddenly get a fraction that doesn't reduce to an integer. Okay, I'm not going to get complex numbers. Okay, just means that they're going to be always integers. So I can then say let M equal L times K, where M is an integer. So I can rewrite my statement as BD equals M times AC. But now, if you notice back to what we did up here, where A divides B is the same as B equals some integer times A, and C divides D is D equals some integer divides C, here I have BD equals some integer times AC. So essentially what we're saying is that, therefore, by the definition of divisibility, AC divides BD. And then we can put our little box there to say that we proved it, or you can go old school and throw a QED there. Doesn't really matter, but essentially that is what we're looking for. Okay, so that's a good example of kind of a basic divisibility proof, and we'll be doing a lot more of these going forward. If you have questions, make sure you ask, and feel free to use this as a model for some of your proofs. It won't work in every case, but it's at least when you're talking about divisibility, it's a good place to start. Okay. Again, some feedback on the dark background, if that works for you or not. I can always switch it back if we find it to be more distracting than helpful. Okay. Thank you very much, and see you later.